Hello ib2 students, welcome for your first video lesson. I hope you're watching the most boring movie, Chernobyl, Disaster at Chernobyl. Which one is better, Story of Electricity or Disaster of Chernobyl? Okay, as you know, we start new chapter, energy production. This is last chapter in the core material. So I hope you are prepared. You have your notebooks, pencils, and eventually calculators, because I think the lesson will be the same as typical ordinary lesson, but except whiteboard you have a computer, and of course I know you cannot see me, I've turned on the camera, but you can see what I'm talking, what I'm writing. Yeah. Okay, so name of the chapter is energy production. Okay, this chapter is in your Tsokos book on page number 314. Okay, so right, first topic, energy sources. Okay, so topic is energy sources. I will be talking, I will be writing, I'm going to give you notes, solving some examples, but if it will be too fast to you, then please stop video for a moment, organize yourself, finish notes, and then turn it back. Is it clear? Okay, so energy sources is our actual topic. First of all, you have to distinguish between primary and secondary sources, so you can write first point, primary and secondary sources. Okay, so what is primary source? Primary source is source of energy which is natural. The best example of primary source is a sun. Is it clear? Okay, so sun gives us pure natural energy. We can use this energy directly. Okay, and secondary source, when primary source is processed, then secondary source is created. The best example is electricity. Okay, electricity is a form of energy created from the burning of fossils. Is that clear? So electricity as a form of energy is not primary source, it's a secondary source. Is that clear? So write first bullet point, primary source. Okay, you have this in your Tsokos here. Okay, is energy found in nature? Is energy found in nature? Yeah, okay, yep. Energy found in nature. Okay, you can write as example sun's energy. Okay, and secondary source, okay, is when primary is converted, processed. Okay, so when primary source is converted, then secondary is created. Okay, as an example, very good example here is electrical energy. Okay, electrical energy is created from, let's say, wind turbine. Remember that wind is created by sun's activity. Okay, electricity is created by burning of fossils. Okay, so fossils are created from death matter. Okay, death organic matter. So also sun is at the beginning. Is it clear? Okay, so point number 2. Let's write point number 2: specific energy and energy density. Point number 2, specific energy and energy density. Okay, the word specific, the meaning of word specific is exactly the same as in thermal physics. Okay, so what is a specific energy? Specific energy is amount of energy which can be extracted from 1 kilogram of fuel. Okay, so amount of energy which can be extracted from 1 kilogram specific mass of fuel. Okay, so what is the unit? The unit of specific energy is joule per kilogram. How many joules can be obtained from 1 kilogram of matter? Okay, very similar is energy density, but energy density refers not to the mass but to the volume. Okay, so energy density is amount of energy which can be extracted from 1 meter cubed of fuel. Okay, so unit is joule per meter cubed. Okay, which one is better? If you have fuel in the solid form, like, I don't know, uranium or a coal, the better is specific energy. But if you have fuel in liquid or in gas form, like natural gas, the better is to use energy density. Okay, so if you know density of the fuel, it's not problem. You can convert from specific energy to energy density and vice versa. Okay, so again, if it's too fast to you, please stop video for a moment, make notes in your notebook, and then turn it on again. Okay, point number 3 is something probably you know: renewable and non-renewable energy sources. Renewable and non-renewable energy sources. Okay, so what is renewable or what is a non-renewable energy source? Okay, the words renewable refers to the term or process how fast the fuel is extracted, how fast the fuel is used. Because if you have a fuel which cannot run out, okay, then it can be classified as renewable energy source. Okay, if you have a fuel which eventually will run out, then it is classified as non-renewable energy source. So this is the best difference. Okay, so renewable means it cannot run out. So what is example of renewable energy source? Like sun. Of course, you can say that sun will not emit light in, let's say, 5 billion of years. But in human life, this period is very long. So we can classify sun as a renewable energy source. So solar energy is renewable. Okay, is wind a renewable energy source? Yes, of course, because to produce wind, the temperature difference is needed. To produce the temperature difference, a sun is needed. Clear? Okay. So what is non-renewable? Non-renewable is opposite to renewable. So the source is non-renewable if it can run out. Example, fossil fuels. Fossils. Like coal, it can run out. Okay, like oil, it can run out. Natural gas, it can also run out. Okay, so this first part of the lesson, I focused on 6 important terms. What is specific energy? What is energy density? What is renewable energy source? What is non-renewable energy source? What is a primary source and what is a secondary source. Okay, so let's stop video for a moment, read these points again, and if you understand all, we can go forward. Okay, so point number 4, let's check energy sources one by one. So in point number 4, let's talk a little about fossil fuels. Fossil fuels. As you know, fossil fuels are or coal, or oil, or natural gas. Okay, first of all, you have to know that fossils are non-renewable energy sources, which means that they can run out. Okay, so fossils are non-renewable. Okay, second of all, you have to know that we can use these fossils by burning process. We can burn coal, we can burn oil, we can burn natural gas to obtain thermal energy. Okay? And of course, this thermal energy can be used in many ways. Because if we need thermal energy, it can be used directly. If we need electricity, we can boil water, make it, turn it into steam. Steam can spin turbine, turbine can spin generator, and generator can create electrical energy. But the key word here is by burning. Okay? If we have a burning process, it means that carbon dioxide is produced. Okay, let's leave this carbon dioxide at this moment. There will be a separate lesson about greenhouse gases, but you must know that carbon dioxide, the dioxide is not is unwanted in the atmosphere because it's classified as a greenhouse gas, and more details, of course, later. Greenhouse gas. Okay. So, what is the scheme of typical fossil fuel nuclear power plant? Fossil fuel nuclear power plant is in your circus on page number, I don't know, but this is figure 8.1, page number 316. Okay, so let me copy this picture here and a few words about this. At the end of nuclear structure chapter, we were talking about typical nuclear power plant. So let's look. Typical fossil fuel power plant is very similar, but except nuclear reactor, we have a place when fossil fuel like coal is burned. Okay, the burning process produces a lot of carbon dioxide, which is emitted to the atmosphere. Okay, so we need a lot of coal, which is burned. This thermal energy is used to convert water into steam. Steam spins turbine, which is connected with generator, which produces electricity. Of course, in each power plant we have transformer, which increases the voltage, and high voltage current is sent to the houses and businesses. Of course, the water, the steam can be condensed, must be condensed back to the water, and it's done usually by external reservoir of water. In this case, it's a river. So again, we have coal, which is burned, so thermal energy is produced. This thermal energy is used to convert water into steam. Steam, when steam is produced, then it changes volume, so it travels through the pipes with very high speed. It spins turbines connected with generator, and electricity is produced. You must know this scheme, and you must know something else, something new, called Sankey diagram. Okay, so right in the same point, still we are talking about fossils. Yeah, maybe here. Okay, here. What the Sankey diagram is. Sankey diagram is a diagram which presents flow of energy. Okay, so energy on Sankey diagram usually flows from left to right, and width of the arrow represents amount. Okay, so in this case, width of this arrow, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares, represents 100% of energy. In each place, in each part, in each stage when energy is lost, arrow is redirected down. In the boiler, 20 out of 100, so 20% of energy is lost, which means that the thickness of the arrow is different now, it's 80. 100 minus 20 is 80. In next stage, in the condenser, 40% of initial energy is lost. So now thickness of the arrow is reduced to 40, because 80 minus 40 is 40. In each stage, in this case in generator or turbine, 5% of initial energy is lost. So thickness of the arrow is reduced to 35% of its original. So finally, our power plant has efficiency of 35%. So Sankey diagram represents the flow of energy. Energy which is useful is directed to the right, energy which is lost is directed down, and thickness of the arrow represents amount. So if let's look at this example again. If 35% is efficiency of all system, then thickness of the arrow at the end must be equal to 35% of thickness of the arrow at the very beginning. And this diagram, which represents flow of energy, is known as a Sankey diagram. Please copy this example, and of course this power plant also. Please copy these two to your notebook. Stop video. When you will be ready, turn it again. Okay, so let's write point number 5. Nuclear energy. Okay, this point will be a kind of revision because we did this point as a separate topic, nuclear physics. It was more than 1 month ago, but you are still experienced. Okay, so what is nuclear energy? Nuclear energy is energy which is stored in the form of binding energy in the atoms. To extract this energy, we need a device called nuclear reactor. In your circus, you have 2 types of reactor. You don't need to... Oh, no, sorry, not 2 types. Yes, 2 types of reactor. You don't need to know both, but let me remind the idea. Okay, so we have fuel in the form of rods, called fuel rods. Okay, in fuel rods, nuclear reactions take place, and due to these nuclear reactions, we have fast-moving particles like neutrons and, depending on the reactor, kryptonium and barium. Okay, these fast-moving particles collide with the atoms of cooler, and in this case also moderator. Okay, so we have energy transfer from the products of reaction, nuclear reaction, to the atoms of cooler. So what happens? This cooler, usually heavy water, is heated up to very high temperature, up to 300 degrees Celsius, and flows through the container containing ordinary water. Due to this high temperature, this water is turned into steam, and this steam is drives turbine, which is connected with generator, and electricity is produced. Okay, so the scheme is very similar to typical power plant, but except a boiler, we have a place called nuclear reactor. We have a device called nuclear reactor. Okay, typical reaction of this you have here. In this particular reaction, nuclear fuel is uranium-235. If uranium-235 is bombarded by neutron, then what happens? It's changed into isotope of uranium-236, which is unstable, and it decays very fast into xenon, strontium, and 2 more neutrons. Here you have to know terms. I'm not going to repeat these terms. You have this in your notebook. You have to know terms. Chain reaction. Okay. You have to know critical mass. Okay. You have to know enrichment process. okay, you have to know some components or elements of nuclear reactor, like control rods. Here, very short revision to control the rate of reaction. And last part, a moderator. Also very short revision. Remember that neutrons produced in fission reaction are too fast and cannot initiate further reactions, must be slowed down, and the role of moderator is to slow down fast-moving neutrons by typical collisions and then to make further reactions possible. Okay? So, okay. And we were also talking about advantages and disadvantages of nuclear energy. So here as a homework, please read this in your nuclear physics chapter, advantages of using nuclear energy and disadvantages of using, of course, nuclear energy. Okay? So again, we were talking about energy production. We focused at the beginning of the lesson on terms like specific energy, energy density, renewable energy sources, non-renewable energy sources, primary source and secondary source of energy. And on the second part, we were talking about typical fossil fuel and fossil fuel power plant and about nuclear energy. I forgot something about fossil fuels. Okay, how are fossils created? Probably you know, but let's add note somewhere here. Okay, what is needed to create a fossil? Fossils are created from old dead organic matter. Okay, and to convert that organic matter into fossil, into coal, example coal, we need high temperature and high pressure. So, other words, compression. This matter must be compressed by high temperature and high pressure. Compression. Okay, and we need very important factor, time. So when that organic matter is kept in high temperature, in high pressure, in long time, it's converted into fossil like coal, oil or natural gas. Okay, how it's done? Because by nature, matter is covered by another matter, by another matter, by another matter, deeper, heavier. So high pressure, high temperature, millions of years, and we have fossil fuels. Okay? So let's stop this lesson now. In our next meeting, we will calculate some examples related with fossil fuels and related with nuclear power plant. Please, your homework is to check your SOCOS pages from 314 up to 320. Okay, 21. 314, 321, so pages 314, 321, including examples of calculations. So during our next meeting, we'll focus on the calculations, and we focus on the calculations related to energy production. Okay, I hope you like this method of, in your case, learning, in my case, teaching. So during our next meeting, I will present next video related with calculations. Okay, I'm waiting for comments and see you. Bye.